Alrighty, let's crack on. Um, so we got up to the binomial stuff slash discrete stuff last time, I think. How's that all been?
Uh, Serena, okay-ish, I guess. I didn't really do too much, to be honest, because I
Hmm.
had a few school stuff going on, but
Yeah, yeah, that's no worries. So just more, it's more so you haven't done much on it rather than not like confused about it.
yeah.
Cool. Okay.
I mean, the lesson was pretty, like, okay, in my opinion.
Yeah. Yeah. Okay. Sure. So I guess my question would be then: are you looking to use this time to practice more of the binomial stuff, or are you looking to learn the later stuff?
Probably just go over it again and then
Hmm? Yeah. Sure.
practice.
Okay. Binomial and statistics for binomial. Cool. Okay. So binomial, it's a specific kind of discrete probability which has to meet the following criteria here. The one that you care about most is going to be the fact that there's only two possible outcomes, either a success or a fail, head or a tail, rolling a six or not rolling a six. These are the kinds of things that scream binomial. Um, that's going to be your first indicator. Just, probably want to keep in mind the other two just in case there are some circumstances where that first indicator won't be indicative of binomial specifically, but it's a very good indicator. Um, the other key one to look for would be that repeated trials are independent. So when you toss your coin a bunch of times, it's the same as if you had tossed it for the first time. Nothing has changed. You're just repeating the same thing over and over. This is where you have things like when you're replacing things or returning things back to where they came from before starting the next trial. These are indicators of whether you're doing a independent set of trials every single time. Once you've identified that your probability is binomial in nature, you solve those probabilities, at least tech-free, using the Bernoulli sequence, which has the NCR equation at the very start, basically calculating the number of combinations of which you could have those outcomes, and then multiplying by this stack of probabilities, p being the probability of success, 1 minus p being the probability of a fail. N is the number of trials, x is the number of successes that you want, which is why this one's power of x and this one's n minus x. So probability of success and number of successes, probability of fail and number of fails, in other words. First example is to figure out how to calculate just a very basic, what's the probability of this one specific thing happening? Well, that's just one Bernoulli sequence. Coin is tossed 5 times in a row. Probability of tossing 4 heads. Well, you're tossing it 5 times, n is 5. You're tossing 4 heads, and we're going to consider head tossing to be a success. Doesn't really matter if you call it a success or fail in this case because the p-values are identical. It's just 50-50 no matter what. But yeah, just sub in the spots, simplify, and as long as you know how to simplify your factorials, this should be chill. Cool.
Yeah.
Okay. On the CAS, binomial PDF. Remember what that is on the CAS?
Was it menu 5, A or B?
Yeah. Yeah, it's in those spots. That's it. If you have to solve a range of probabilities over a given domain, for instance, like one or less heads, then tech-free, you're just, again, like you would for discrete, you add up all the outcomes that are in that domain. So it's one or fewer, which means you want to have one or fewer, all the way down to 0, which is usually where most things will cap out. Specifically in binomial, it'll always cap out at 0 because we're talking about things in terms of number of successes rather than like when we were doing those games of chance where you could have like -$1 and $1,000 as payouts and stuff like that because it's thinking about things purely in terms of number of successes. You actually do now start at 0 and end at n. But cool, okay, just adding them up after simplification. and that's where you're going to use the binomial CDF in the CAS where applicable. That's going to be the B option. The A was the PDF. It's often really helpful to use complement probabilities to sort these things out tech-free. Like for instance, if we're tossing a coin 5 times and you want one or more head, you don't want to go x equals 1, x equals 2, 3, 4, and 5 and add all that up. That's a pain in the ass. Instead, you just say, well, the only thing that's not in that domain is x equals 0, so I can use 1 minus that to get the thing that I actually want. Cool. And lastly was like a CAS approach here. This is just sort of extending that a little bit more. You shouldn't need to do any of this. You would probably just use the guess and check method that we... Alright, we shall pause. Welcome back.
Yeah, sorry about that. Zoom strikes again.
Yep, indeed. Did you get that last example before you left?
No.
Okay. Basically what I was getting at there was if you have a scenario where you're trying to do like x greater than or equal to 1 and you've got an n of 5, you don't want to do x equals 1, x equals 2, 3, 4, 5 all the way up until then. That's a lot of calculations, tech-free. So what you can do instead is say, well, x equals 0 is the only one that's not in that domain, and so you just do 1 minus the x equals 0, and that'll get you what you're looking for. Cool. There's a CAS approach.
Yeah, it's cool. Cool.
Yeah. This is a more, like, we don't really have to do this at all. This was more so just to extend a little bit on the theory of like using complement probabilities. Like for instance, if you had x greater than or equal to 2, you would have to do 1 minus the addition of x equals 0 and x equals 1. You wouldn't really solve this question this way, though. I mean, you would if you were forced to do it by hand, and then you had to sort of, I don't know, guess and check your way through this, but that'd be a pain in the ass. Instead, you would do, because there's always be a CAS question, you just do the more effective guess and check on the CAS. Do you remember how that one worked?
Was it like changing the bounds?
Yeah, precisely. So usually it's a fixed lower bound and an unknown upper bound. Otherwise, if it was an upper bound fixed and unknown lower bound, well, that lower bound, yeah, I mean, I guess that could be doable. They've never done it before where they've made the lower bound the thing to search for. But yeah, all you're doing is just guess check n until you get the probability you're looking for, which is 0.9 or greater. Cool. Those are the probability side of things. Statistics is significantly easier. You just need to know what's n, what's p, and then you can solve literally all the binomial statistics. N times p is the expected value, otherwise referred to as the mean. The variance is np1 minus p, or sometimes it can be helpful to remember that np is also the mean. So if you would have calculated that earlier, tech-free, it'll save you a single calculation if you recognize that, oh yeah, np is mean, I don't have to do this multiplication again. Cool, got it. It doesn't save much time, but it's cool to know. It's more so applicable for when you're doing like these little simultaneouses over here, where if you know the mean and standard deviation or variance or whatever, if you know two of those statistics, because they both just have n's and p's in them, you can solve them simultaneously. But rather than having to do what I did here, which is rearrange and then sub in one of the unknowns, because np is 4, you just smack a 4 here and it saves a little bit more time. So that's the only reason why you probably want to pay special attention to the NP. Otherwise, yeah, these are just basic calculations of N and P. They exist on your formula sheet. You'll never need to remember them unless your SAC, for whatever reason, decides to be a pain in the ass and not put that on there as is standard. But yeah, here's a quick example when finding the statistics. Again, all we're looking to do is figure out what's N and what's P in the scenario. 3 balls are selected, so that's going to be N is 3. And we're told that we're tracking the number of white balls selected. So when we're talking about P, the probability of success, we want to know the probability of selecting a white ball, of which there are 5 out of a total of 8. You have N, you have P, sub in and solve. This is where confidence intervals start actually making sense. Confidence intervals need a fairly large sample size before you get decent, reasonable results, stuff that actually matters. The basic premise here is that you're trying to find a domain such that X% of results are likely to fit within. So a 95% confidence interval would simply just say that we are, when doing this experiment with the given N and P parameters, 95% of the time we're going to get a result between some upper and some lower bound. Like, for instance, if you take groups of 400 students and figure out how many of them went to public schools, if you calculate your mean and standard deviation and sub into the equation, you'll get anywhere from 304 to 336 in any given sample of 400 students. But again, that's just calculating mean standard deviation and then putting a bit of addition and subtraction in there. Those are the fundamentals. Any questions?
Not really. So you see these like how there's the formulas for calculating mean, variance, standard deviation.
Mhm.
So like the ones with like NP and stuff, like because we didn't do this, I think last time. Are these like the ones when you don't have a probability table, or
Yeah, typically when it's binomial, you don't have a probability table simply because, I mean, you can. Yeah, there's no reason why you shouldn't have a probability table for binomial because
I just
your
don't do it.
probability table is just saying the outcomes of the scenario. And so if you're thinking about things in terms of success fail, it's just going to be how many successes or fails on the top. But yeah, you typically don't get a probability table with this stuff. You have to
Okay,
go.
like, is it okay if I just write down those like
Oh,
formulas?
yeah, sure. A lot of them are just repeats of each other, showing you different notations and stuff. Let me know if you want the Bernoulli sequence afterwards as well.
No, I got the Bernoulli sequence last time.
Yep,
This is just new.
yep, cool.
I actually had my first ever methods class today
Oh,
because
brilliant, yeah. First actual methods class. Because you're doing Head Start now. Nice.
yeah.
That's a 2 week thing?
For our school, like 2 days.
Oh, it's only 2 days. My God.
3
Okay.
days. It's just like I guess you get to meet your teacher and they get to give you the holiday homework.
You get 2 days of it, and it's like, cool. Now do the now do several weeks of holiday homework. So you guys will
But
finish earlier than a lot of students, a lot of other people, then, yeah.
yeah, 1st of December. So this Monday.
That's December. Yeah, hell
Yeah.
yeah.
And I have work experience after that. So
Oh, nice. Where'd you land work experience?
Clayton, it's a accounting firm. I know the person who runs it.
Oh, cool. Nice. An accounting firm. Fair enough. And how long does work experience usually go for?
1 week.
1 week. Oh, okay. So really, really chilled. You're basically just gonna go meet the staff, and that's about it.
Yeah, probably. Maybe a few calculations here and there, but that's about it.
Yeah, you might shadow someone doing a balance sheet or something like that. God,
Yeah.
it's been forever since I did any accounting stuff. It was just in well, I mean, I guess I do accounting for this, but formal accounting work
Well, I think
in
it's like all
school.
digital now, from what I've heard. Like no one really does like much manual accounting anymore.
Hmm. Yeah, I mean, a lot of it can be automated.
Apparently, this is more just about like an analyzing the information and then giving like advice based off that. That's like the
Yeah, it's
extent
more
of it.
we don't really use, I guess, the words accounting anymore. It's usually finance now.
Yeah.
It's the analysis of those things. You're exactly right. Yeah, because you never want to be in the dark when it comes to, hey, where exactly is the money being spent, and can we put it in a more effective spot? So that'll be a
Like,
nice little.
I do VC accounting and they say like in real life, all the data doesn't really mean anything if you can't put into words or like
Yeah, precisely.
consult
So
people.
you've currently done VCA accounting, the first unit, or
Yeah. One and two is done.
yeah?
Doing three and four. It's what
How'd you
year.
find it?
It was good. It was not too bad, to
Hmm.
be honest. It's not too theory intensive. It's just more like because the theory is not that hard. You need to be like basically perfect to like
Yeah,
mark the top.
yeah, it's fairly accurate because the actual the theory is typically fine. The calculations are definitely fine
Yeah.
because it's literally just addition subtraction. I don't even
It's
think.
like a general maths like sort of vibe, I guess. You can
Yeah,
compare.
knowing where to put the things on the balance sheet, you got to be very locked in with your asset liabilities definitions.
Yeah.
Um, they separated between what was it? There wasn't just asset liabilities. There was
Owner's equity
short
as
and
well.
long. Hey,
No, no. Yeah, there's current and non-current. So like,
that's it. Yeah, current, non-current.
and then there's also something called owner's equity, which is like the capital
Yeah,
and
yeah, capital. Yeah, okay. Not too much has changed then. A
did
lot
you
of
used
it's
to
still
do
the
it as
same.
well?
Yeah, yeah, I did it
Okay.
in VCE 2018. So even now 2025, not much has changed in it apparently.
Yeah, not too much.
But fair. No, that was decent. If you got a decent, because our teacher for accounting was someone that actually had run a chain around a Donut King, um, and so they were able to bring in their actual ledger book of when they were doing balance sheets and stuff.
Okay.
So that was kind of cool to see. But yeah, okay, got those equations now.
Yeah.
Cool. So, would you rather focus on the statistics side of things, this one, or back to the probability side of things?
Um, probably so.
Yep, sure. Okay. Um, question one, I guess, getting a decent bit of theory behind it, just figuring out, hey, do I have a binomial experiment or not? Is this a scenario where you would have a Bernoulli sequence? So it might be worth having a look at those, just quick fire maybe.
Uh, like the first question is like multiple choice. So I'd
Uh,
say,
not multi-choice, no. They're all individual, I believe.
oh, what? It says which of the following describes a Bernoulli sequence. I thought it'd be
Yeah, you're right. You're right. It does sort of seem like that. But I will say, just sort of looking at it briefly, a lot of them are valid. Like tossing a coin many times, you got to say, are there two outcomes and are the trials independent back to back?
yeah. I mean, also because there's yeah,
Hmm.
and there's like a probability of success for a fair coin, which is like half.
Yeah, yeah. The next one, you've got five red, three black, and the ball is replaced every single time.
That's also a Bernoulli sequence.
Yep, that's good. So I guess the lesson there is it doesn't have to be 50-50 all the time. In fact, oftentimes it's not. Different ages.
I don't, I don't think that's like Bernoulli sequence, is it?
Why?
Actually, no. Scrap that. It can be, but you have to have like a you would want to like know like have something defined as your success range or
Yeah,
number.
yeah, okay. I think the intention here is that you're literally just going at random and picking people's ages and those are the outcomes.
Right.
So in that case, no, but yes, the nuance that you put on there, which is, oh, if we're looking for greater than 40 people or whatever, then yeah, you could use that data to then calculate probabilities and make it binomial. But yeah,
That's not a
sex, male or female.
I don't know if it's a Bernoulli sequence because it's more than two different outcomes.
It's more than two outcomes.
Yeah.
So one outcome.
No, I said there's more than two
Oh, there's more
outcomes.
than two outcomes. Out of, I mean, I guess if we're going, yeah, if we're going into gender and all the permutations there, but they've specified in this circumstance male female, which would be two outcomes.
Oh wait, my bad. Misreading the question. Wait, so isn't that also just a that would also be a Bernoulli sequence?
Yeah, it would.
'Cause you'd have to just like define what whatever your success is, male or female.
Yeah, yeah, correct. Mainly, um, I mean, we use the keyword success kind of just so we understand it a bit better. We don't really need a success or a fail. We just need to know um, the probability of outcome one and then the number of outcome ones, which is going to be this bit, and the probability of outcome two and the number of outcome twos. And simply because it's one or the other, one of them is always going to be the complement to the other. So technically, on a very nuanced level, you don't need to call it a success or a fail. You just need to have um, directly opposed outcomes.
Right.
But yeah, that's just semantics. Cool. Okay. And these are just the actual calculation side of things.
Yeah.
Probability of four heads when tossed 7 times. Um, do you want to practice the arithmetic on that or just sort of get through it CAS wise?
Uh, I just bring my cat on and do whatever has.
Yep. Easy.
Question two.
Mhm.
All right. 35 on 128.
35 or 128. Let me just double check that because they gave me in decimals 20.
In decimals, I'd be like 0.27.
Yeah, 0.273. Yeah, that's good. Easy. Yeah. N is 7, probability of success 0.5, and I'm assuming you did a PDF there.
Oh no, I didn't do the PDF. I put it straight into bin. I put it into Binomial.
Oh, you did. Okay, understood. You did the
I'll put it
sequence
into
on
PDF
the
next time.
CAS.
I don't know why that thing didn't cross my mind.
Well, that's fair, no, because as long as you're really comfortable with your arithmetic, then yeah, you do want to make sure that you're able to plug them into the right spots and make sure you get the right answer from it. So that's fair enough. But yeah, PDF. If you're required the CAS, then yeah.
3n for a normal distribution of n is equal to 4 and p is equal to 0.2.
Yeah. So just an even more straightforward version of question two, where they just tell you N and P off rip. Might as well, yeah. We'll tidy that one up and then I'll see if there's anything unique in there.
What? 0.025
0.025, yeah.
and .0016.
Correct. Yeah. Judging by the duration of time for the answer, I'll probably assume you didn't use a bit of a shortcut here, which is like, let's say you got your first binomial PDF and you got it there. One of the things you can do is literally just grab a copy of it and then just change the parameter in
Yep.
there, making it a massive time save in the real deal.
Yeah, I didn't do that.
Yeah. Um,
Yeah, that's 10.
but all good. Yeah. But again, these are some of the questions. It's just going to be what's n, what's p in the scenario. Let's see if I can find anything unique. Write down the rule. So that'll be actually getting you to force you to do the actual Bernoulli sequence, write it out,
Oh, yeah.
and then using it. Sure, but you've already demonstrated you can use the rule fine. Write the rule exactly two, more than two, at least. Yeah, maybe get your head around the inequality versions. So you're not just doing x equals
Probably.
something.
Data is rolled since time the number of twos is noticed. Greater than inequality of more than three twos. More than three twos. Would that just be look at the probability of up to three twos and then subtract that from one?
Yeah, that's fine. You could do the complement version of it. Um, tech uh, tech active, you don't really care because you just put in exactly what it says and then don't have to think harder than that.
But more than three twos, then isn't there like your x value would be like four, five, and six, like
Yeah.
can you thing in a PDF, or do you have to like do separate PDFs and then
Oh, so you'll do CDF if you're looking CAS. CDF will do the whole thing if you just do lower bound 4, upper bound 6. As far as
okay.
tech free, what actually is easier? So more than 3 is the 4, 5, 6, like you just said. Otherwise, you're doing 0, 1, 2. Oh, sorry, no, 0, 1, 2, 3. So I guess both ways you'd want to do. You wouldn't probably want to do the complement simply because there's one more thing to calculate for the complement. But otherwise, yeah, the CDF is usually going to be the way to go.
Is four. Oh, okay. 0.0087.
That's it. Yep. This one slightly different, only slightly. At least 3 twos.
Oh, okay, I see. Actually, I'm just gonna copy that thing over.
Yeah, there you go. So the CDF is slightly harder to work with because you've got to know what position each thing is, which one's lower, which one's upper. But they usually do it if it goes top bottom, then on the screen it'll go left to right.
Yeah, I got .062.
0.062, yes, 0.062. Smashed it. Okay, 10 tickets. So NP rule, no wins, at least one win. Um, N rule, yeah, either x equals or inequalities. Yeah, this is where things start getting a bit weirder because if you're not doing this in a chapter specifically on binomial distribution, you now have to consider the wording of something like this, which is basically calculate the probability of rain on 2 or 3 days. Um, if it's specified what days the rain had to be on, you can't really effectively use binomial anymore. Like, for instance, raining on day 2 does not mean x equals 2 because x equals 2 means 2 successes, so 2 days of rain. Under those circumstances, if you did have specific days it had to rain on, you would have to now default to something like a tree diagram or other discrete methods of getting there. In fact, probably only the tree diagram would be the more effective way because each set of branches would be a unique day. Um, even if the thing is inherently a Bernoulli sequence, if the question is worded in a way where it doesn't actually care about number of successes, but when the successes occur, it's not, you can't really use a PDF or CDF approach there. This one obviously came from a binomial chapter, so you're going to use binomial, but this is something you'd have to consider when you're looking at an actual exam or SAC situation.
Yeah. Okay, let me. I think I can try that real quick.
Yeah, I mean, this is, yeah, this shouldn't be any different to what you've already done. I just want to touch on that nuance if it was worded differently.
Is it actually no, I think I got this already wrong. For some reason I've got 0.019, but
019. That is a bit
I
off.
don't know.
Yeah.
Yeah. Rainfall on any given day is 1/5.
Mhm.
I thought like this would be a tree diagram approach, right? So
Oh, yeah. Okay.
but I
Um,
don't think you can do that here because that would be also specific days.
I mean, it would work, but for a tree diagram, it's a week. You got to have 7 stages. Not fun.
No, like, as in like, so the chance of rain is 1/5, right? So then the chance of not raining is 4/5.
Yeah. Yeah.
So 2 days is 1/5 squared, and then times four and
Uh,
five.
well, yeah, back to back it is. Yeah. And so, yeah, I mean, I guess you're right because, but now you got to do the NCR on that as well. And then because, you're not looking for just success, success, fail, 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 or for 3 days, triple success, double, oh, sorry, more than that, 7. Um, but then you're getting literally into doing the Bernoulli sequence with extra steps. You're doing, this is how many rainy days, this is how many non-rainy days, and this is the number of ways that you could have rainy days arranged. That's, you're basically just doing that in 3 separate stages. Um, but yeah, like a tree diagram will work with this thing if you're using a tree diagram specifically because you want to see all that information. That'll be quite big. What's that? 2 to the power of 7. A lot. A lot of branches. At the end, anyway, because you got to. Not only do you have 2 to the power of 7, but you have. Oh, do you actually? Yeah, it's 2. Then the next stage is okay. So you have 2 to the 7, 2 to the 6, 2 to the 5 on the same page. Anyway,
Okay, so is it 0.39?
yeah, 0.39. That's it. Couple ways you could have done that. You could have done the x equals 2 and added it to the x equals 3, or because those are back to back, you just do a CDF from 2 to 3. That works simply because they were back to back. If it said x equals 2, x equals 4, then well, now you can't really do a CDF there, or you can, but then you subtract the x equals whatever's in the middle. But that's just getting weird. Cool. Okay. P N target.
Today, like in class, the teacher that we had, he's like a special teacher,
Yeah.
and like brought up like an exam question, and it's like really funny. Like three, four exam question on the first like lesson.
Oh sure.
Shows like what matters life.
Wait,
It's really
so hang on.
funny.
Special teacher, and you're taking special?
No, I am, but
Yeah.
he was teaching methods, so.
Okay. Yeah. Yeah. Cool. Yeah, that's cool. Do you recognize which one it was?
Um,
We've done a
I
lot of them
wouldn't
here.
just tell you. I think I don't know what I don't exactly remember what exam it was. It might be 2023. But you know, like there's those simultaneous equations where like they have like a y.
Yeah. Yeah. Yeah.
Also like unique, infinite, and
Mhm.
no solutions. Is it one of those?
Yeah, yeah, okay. Yeah, we've done a lot of those. That's a fairly common question
Yeah,
that come
that's
up.
pretty easy. The
Nice.
funny thing, because the funny thing is, a lot of people in our school, like in my school at least, maths is one of the like worst performing subjects, even though it's a selective school.
Mm, interesting.
Because a lot of people just do it because everyone else is doing it. Because yeah,
Yeah, they don't want
because
the stigma of doing general.
people who do spec have to do methods, and then the people who do general they also just do methods for the fun of it. So the
That's
people
interesting. Okay, I would have
who
thought.
aren't necessarily good at maths, and then they just do methods.
Yeah, that's actually kind of interesting. I would have thought the reason you do methods is because you don't want to have the stigma of being the general kid. But I guess doing both general and method is interesting. But I guess that does give you an easy subject selection, general,
Yeah,
because sometimes you just don't have
prereq.
that many things that are interesting
Methods are
to
the
you.
prereq for almost anything. So it's another.
Yeah, methods are prereq for a lot.
Our teacher was like showing us like his like kids' scores from this year, and like some of them like scoring in the single digits, like percentage on the
Oof.
test. Yeah, it's pretty rough.
Done in this way. That could use some support. Or because yeah, even the lecture recordings of these are available on YouTube and also in the past recordings thing. So even if they don't join the program, they can at least maybe get something out of it similar to what you got, even if they can't necessarily afford it or aren't that inclined to pay for it.
I mean, I feel like it's not that like methods isn't even like that hard compared to year 10 or year 9 maths. It's just
Yeah.
part is just your drive. I guess if you're just doing it because everyone else is doing it, you're not going to be motivated to do like the subject either.
Hmm. I mean, I'm assuming they've done it partly because yes, people are doing it, but also partly because it's probably a prereq for what they want. Um, at least I don't see why you'd put yourself through methods if if it wasn't a prereq.
Yeah,
Not that it's, again, as you said, it's not particularly hard. No individual concept in methods is too hard. If I were to take a stab at it, maybe transformations or the counting method stuff would be the stuff that people typically find hardest to begin with. But everything else is fairly chill if you look at it in isolation. It's more so, okay, cool, you've got everything, now figure out which thing to use in this scenario. Like
yeah,
probability is really, really good at giving you that kind of grief because it's like, cool, all these questions look like the same sort of thing. It's just find probability of this thing happening or find the statistic in this scenario. You got to go through your list of, okay, which probability is it? There's 5 possible outcomes. Cool. Okay, so it's this type. That means I got to use these equations.
I mean, our teachers also like, like to make our tests like more reading comprehension than mathematics, but
I don't know.
I don't think it's that bad. You'd be scoring single digits. Like,
Yeah, I mean, single digit is tough to be in that situation because you really just don't want to drop a subject if you can afford it in VCE. Um, Simply because you've got to now catch up a full 2 years within a single year on the subject that you pick back up. And so it's unfortunate that they're in that situation. I would recommend them help. They don't have to drop it. They can get their bare minimum 25 study score or whatever. But yeah. Anyway, cool. I don't think it's going to be much different in here now. They give you some crazier numbers, but if we're using CAS, which we are, there's no way in hell we're doing this by hand. Maybe the x equals. The x equals stuff isn't that bad because it's still just one Bernoulli sequence. But these
yeah,
inequalities, obviously, you're not going to do that by
40,
hand.
40 vanilla sequences would be gnarly.
Yeah.
C would be 40. Oh no, actually C wouldn't be 40.
Well, it's x equals 0 up to 39 if you want to do it. Oh, actually, hang on. Yeah, if you're doing the complement, 0 up to 39 would be 40 separate ones because 0 counts.
I
But
think the
obviously, you would do.
most would be probably B because you can't complement or non-complement. They're gonna be 25 vanilla sequences.
Yeah, either way, it's going to be 25. It's dead center. Yeah. But yeah, anyway. Um, this is where you get like your little reading comprehension things that you were talking about. Probability of fewer than half. So it's like, okay, cool. They told me my sample was 6. Fewer than half. So fewer than half of 6 is 3. Fewer than 3. Got it. There's just one additional step in their comprehension. But again, you're just still figuring out what's N, what's P. Um, Anything in there looking like something you'd want to touch on, or is this all straightforward enough?
Nah, it's all good.
Here are the statistics side of things. So you might start recognizing these from either stuff you've already done or stuff we've done together in the
Okay.
classes. Um, you've effectively got a normal distribution there if you
Yeah.
have a large enough n. Um, Obviously, the smaller the n, the less and less it's going to look like that. But your p-value is effectively the mean. Oh, sorry, your n and
Probability,
p.
probability of success.
Yeah.
Yeah. Yeah.
So your probability of success is essentially going to shift whereabouts it is horizontally speaking in the distribution. Lower P means it's going to favor the lower number of successes, higher P means higher successes, which makes a ton of sense. Yeah, it's more likely to happen or it's going to happen more times. Um, yeah,
Yeah.
those are just the equations again. That's what you start seeing your. I like to say interpreting the interval. That's kind of why I touch on like what does it actually mean? What did we just calculate? It's probably worth highlighting. What do they actually use for their wording? The owner of the business knows there is a probability of about 0.95 that from 12 to 28 will, yeah, okay. So it's essentially saying whatever your confidence interval percentage is the percent likelihood that from some lower to some upper is likely to happen given that sample size. That might be the only other thing I touch on this would be to say of the employees, I guess of the employees specifies that yes, we are talking about this sample size. Whereas if it was something more vague like the 400 students sampled, you would say any given sample of 400 rather than of the employees. You just want to have some sort of, I think you want to have some sort of statement in there to specify it with respect to this sample size. It's a slightly more nuanced approach to, or a slightly more nuanced explanation. These are basically time wasters, although I will say a nice way if you want to do these things maybe in your own time. One little trick of the binomial PDF, if you leave the X option blank, you get the full array of probabilities. And so if you're, for whatever reason, inclined to draw this probability distribution, drawing your 8 little dots, just set n is 8, p is 0.25. In fact, I'll just do that now. N is 8, p is, oh, that's 2 decimal places. Can't do that. And, well, that's not pleasant. Maybe I grab a copy of it to get fractions. Still not really that pleasant, but point is you get them all in one array rather than having to do x equals 1, x equals 0, 1, 2, 3, 4.
Yeah. I mean, hopefully you kind of get fractions like that.
Yeah, you don't have to do this. This has never been required in an exam, and we've done many of them, so we can be fairly confident. We got a 95% confidence interval of 0 to 0. Just not going to happen.
Okay.
Um, Pairing distributions. This is more so just like, hey, what we talked about before, which is different p-values are going to shift it left and right, and different n values will, I guess what do you actually say for different n values? You probably comment on the, I'm curious actually, because I want to comment on the normal distribution shape of it, the bell curve shape. I guess I don't really say anything about commenting on n. They just say compare the two. I'm curious if they touch on it. 14b. Sure. Okay. Taking it as a transformations approach, and rather than just saying a horizontal translation, it's a reflection in the line x equals 5. Um, or in other words, it's symmetrical about x equals 5.
Yep.
Did they superimpose them on the same thing, or did they just not draw the second one? So the AB. They did superimpose them on the same axis. If they just, I maybe I'll get that if I actually plot it myself, but to me that looks like it's just incomplete. Anyway, here's the stuff you're probably looking for. Just do a very basic quick calculation for mean variance. Those are kind of freebies though, but at
Yeah,
least maybe do like one of those, and then we can
yeah.
move on to a worded version.
Okay. How do how do how do you see? I mean, the mean is gonna be 500 over 3. It
Yeah, for C, 500 over 3, yeah.
doesn't say decimal places, so I'll just leave that as that. And
Yeah, that's fine.
and the variance is gonna be like 1,000 over 9.
Yeah, better than over 9. Easy. Let's see. So from here on, oh, they've even chucked in some of the previous thing as well. Oh no, they haven't. They've got us to calculate NNP off of those things. Yeah, okay. Maybe try one of those. You got the mean of 12, variance of 9. From that, figure out NNP. If you want, you can do the probability thing as well, but we've done a lot of those.
So it's gonna be like a simultaneous almost.
Yeah, it's going to be simultaneous, basically.
Okay, it's interesting.
I always found this interesting because given that it's binomial, if all I told you was the mean and standard deviation or variance, you just know what N and P were, the number of trials and the probability of success. It doesn't feel like you should be able to get that, but you can.
Okay, so the like n should be 48.
Mm-hmm.
48 trials, and then p, so the probability of success will be 1 in 4.
Yep, 1 on 4. Nice and simple.
X equals 7.
Yeah, if you want to do that, you can now.
Sure, I'll do that. 0.03.
Yeah, 0.03. Sweet. 8 is just a repeat of that. And 9 and 10 are where we're doing those confidence interval stuff. So, yeah, a bit of basically question 4 and then doing a bit of post-processing on it.
If always tells 20 times, find the mean and standard deviation. Calculate minus 20. Okay, the mean should be 10, and
Mhm.
I'll just quickly do the other thing.
Yep,
Times. Okay, the standard deviation should be root 5.
yep, root 5.
So,
Poses a bit of a challenge for us.
okay, hold on. That symbol for standard deviation variance. That standard
So,
deviation, that symbol?
yeah, so standard deviation is the symbol, and variance is standard deviation squared.
Okay, yeah. Yeah. U plus minus 2 standard deviations.
Mhm.
I mean, that's gonna be 10 minus root 20 and 10 plus root 20.
Yeah, yep, that's about right. Now
So
it's on the interpretation side of things. What did we actually just find there?
that oh, okay, I think I know what you mean.
Hmm. So you give that to the layman.
So you want me to like find which one is the nearest whole number?
Uh,
Sorry?
so that's actually a good point. Like, do you do it to the nearest whole number? Um,
I
would
mean
this?
the round up to the is it round up?
Yeah, that's what I'm trying to think myself. Do we round inwards like we would do for discrete earlier when it was like x less than 3.5 is the same as x less than or equal to 3? Do you round inwards in this one
You
or
would
do
want to
you
round outwards, in my
outwards?
opinion.
Yeah, I think it's outwards. I think I like that better.
I think is it going to be 5 and 15?
Uh, they need 6 and 14.
Wait, hold on. But isn't it just two numbers?
Isn't it two
Mean minus
numbers?
two, the standard deviation, and mean plus two standard deviation.
Yeah, but you said 5 and 13. They said 6 and 14.
Oh, I said 5 and 15.
Oh,
Okay.
5 and 15. Sorry. Yeah, whatever you said. It was the one they've got here is 6 and 14.
Okay. Interesting.
So what did
So
the decimals actually come out to be?
4.47 for me.
4.47, and the other one was.
The other one was, well, it was going to be 4.47 anyways, because
Yeah, but so that's the lower bound. Upper bound was.
the upper bound, that would have been like 14.
Maybe the book's done it a little bit weirdly. Let me just double check this. So mean is 10. 10 plus 2 times root 5. 10 minus 2 times root 5. Oh,
Uh,
okay. Your number's a bit off then.
no, I get what you mean. I did 2 root 5 and I just like made that 5. Like just
Oh,
like that,
sure. Yeah, okay.
doing the cool thing. That makes sense.
Yeah, so what do they do
I don't
this
know why
one?
they rounded
They.
it, they rounded the other one inwards, the 14.47.
Hmm.
I thought that should be
14.4 went
repeated.
in, 5 went up. No, okay. So I guess this is more consistent with how you handle discrete when you have decimals, which is you round inwards on both circumstances. So 14 went down and 5 went up. So
Okay.
14 went to 14 and 5 went to 6. Um, because what you have is pencil. It's like those probability tables where you've got outcome 0, 1, 2, 3 as your things, and then they're saying find the probability of being between 0.5 and 2.5. Well, yes, that means these, but because those don't exist, you truncate to here and here, you round inwards.
Okay.
So that's consistent with that. Um, I think the only thing I was maybe considering was in the context of saying it's a 0.95 approximate probability. It didn't say, it just sort of said interpret it. And so approximate 0.95 doesn't mean 0.95 or above. It just means around 0.95 approximately. And so I guess that's why it's fine to round inward. Um, but yeah, so as far as actually interpreting that, right, we got our numbers, which were, what, 6 and 14? So you've got this interval 6 and 14. What does that actually mean in the context of this scenario?
I mean, there's like a 95% chance that you'll get, like, the amount of heads you get, it will be between 6 and 14.
Basically, yeah. Um, you touch on the 0.95 chance, you touch on the fact that 6 and 14 is the number of heads. The only other thing I'll probably touch on is to say any given sample of 20 coin tosses is going to result, 95% of the time, is going to result in this number of heads, or this
Yeah.
range of heads. But yeah. That's just another version of that. You've got your p-value, you've got your n, and it's the exact same thing then. Cool. That's that. And then 14C is the last thing we had to look at in the probability chapter, which was doing the whole guess and check your way through it.
I guess there's a really big emphasis on practice in probability, like because the stuff is not that hard, but if you don't practice it,
Hmm.
it becomes
Yeah.
like really hard.
Um, I don't. I mean, I think that's going to be true of all the topics. Everything is not necessarily that hard in methods, any one thing, but you've got to be able to recognize, not even just practicing it, because I know some people will practice the entire chapter, but not really take away anything from it. The real skill is identifying the key wording and then understanding, oh, okay, these are the things it's touching on. This is the kind of question it is. Like, as soon as I see least number of games, I don't need to know it's chapter 14C. I know that I'm doing the whole N guessing thing. I don't really even need to read the rest of it. I mean, yeah, you're probably going to look for, is there also a target probability in there? That'll also help with it, but it's that pattern recognition that's going to matter a lot. So,
Yeah.
however many times it takes you to practice to get that pattern recognition is more what you're aiming for.
I mean, I guess what I was like alluding to is a lot of topics that have some sort of overlap, like say
Hmm.
functions and relations. We almost see that all the time with integration and diff.
Yeah. Yep.
Like diff, you can use it for like finding turning points or polynomials
Hmm.
or anything really and stuff like that. But this is just like exclusive probability.
Yeah, it's its own little section. And then pseudocode came around and became its own section again.
Yeah.
A very, very tiny section.
Yeah, I remember you like my very first lesson with you. You were like teaching that pseudocode.
Oh, was it?
Yeah. I was
What
like,
a
what even? I was like, what even is this? I was
yeah.
like,
Did I make it to a methods class? What the hell is going on? Teaching code and methods? Unheard of. And it was unheard of. It was only this study design that did that. Yeah, probably it was probably a net good change because otherwise you'd have to be doing matrices, which I always found quite shit. They're not bad now because I've just done enough math to where it's not bad, but it it would have been if matrices were still in the study design for methods, it would have been the third thing I would say, alongside transformations and counting methods that a lot of people would struggle with.
yeah.
But okay, if you've seen one of these, you've seen all of them. Only thing you'd have to pay a bit of attention to is whether you're doing x greater than or equal to 1 or x greater than or equal to like 2, at least once, at least twice. So paying attention to what those upper and lower bound parameters are is the main thing. P is usually extremely easy to find. And the target probability you're looking for is also kind of easy to find. More than, less than a certain thing. Probably jump straight into 1B on this and see if you can, using whatever method you want, get your way through it.
Probability of a target shooter hitting the bullseye on the shot is 0.2. Okay. What's the smallest number of shots a shooter should make to ensure a probability of more than 0.95 of hitting the bullseye at least once? Okay, cool.
The wording
So,
is always strange, but it's because they, you got like, what was it? I think we counted last time 3 pieces of information in one sentence.
cool. of more than 0.95 or hitting the bullseye at least once. I want to say they have to do the confidence interval, but more than
Oh, okay.
0.95.
So you're still trying to get the overall approach. Yeah. So this is this thing where you've got a target probability that you're trying to hit, and you want to figure out n, the number of trials to get that target probability.
The
Um,
middle sequence.
well, you so you can do stuff with the Bernoulli sequence if it's sufficiently easy. Like if there's only one Bernoulli sequence in there, things do simplify enough to where yes, you can do a lot of by hand and solve with logs. You still need to get to a decimal anyway and then round it properly. So there's no point doing all this. This is what I was talking about with the guess and check method via CAS. So
Yeah.
what you do is going to be 55B to get the CDF going. First, identify number of trials, which is, oh, sorry,
Unknown.
that's the unknown. P is going to be zero point 0.2 from the start of the question.
Lower bound's gonna be one,
Well, that's
and
going to be
then
one.
upper
And
bound is try like five maybe to start.
yeah, go 5. That's going to be your N as well. Zero point 0.6. So we go up a bit. You know, you just keep changing things. That's a bit big, but not too much bigger. That's a touch small. Just right.
14.
14 is correct. Yeah. If it was at least twice, you're just putting that lower bound of 1 as now a lower bound of 2, and then the exact same procedure. That's all you need to be able to do. So you need to identify what's lower bound and what's P. Everything else is guess and check. And I guess you need to identify what your target probability is as well, so you know when to stop. But those are usually fairly obvious. They're usually quite big probabilities, like 0.95, 0.7. This one's a bit of an outlier. Oh, actually, now that I'm looking at it, you got some lower ones here as well. But I feel like every time I've seen it show up in like an exam or anything, it's usually a big probability. Anyway, um, so maybe that'll be the one to practice a few of. Otherwise, yeah, I feel like at this point you're solid enough on Bernoulli on binomial stuff.
Yeah, just practice, I guess. Just gotta keep
Yeah,
it practice in
just
your mind.
yeah, get the repetitions in. Um, and if you want to have a look at some 14D stuff, there's no actual question in here. It's purely just for your own interest. If you want to see some
Real nerd. Yeah.
full nerd. All right, I'll leave you to it.
Cool. Thanks.
Till next time.